And now I really want to go into the very interesting part, which is token bonding curves. This is something that's quite new, and there are projects using it right now, and I just want to share this with you because it can be very useful to your project. Okay, so if I can summarize token bonding curve, it's basically the token prices change with the token supply. Very simple, very easy. So I've already explained how token bonding curves work. Basically, you have a function. This function is governed by a smart contract. Smart contract will figure out the prices based on tokens, based on the supply. That's a general gist. But what's the real value add? Why do people want that? Basically because it's an automatic market maker. It provides instant liquidity, and you don't need it's governed by mathematics, and then it always provides instant liquidity. The smart contract will constantly mint or burn tokens based on the demand and based on the curve. So there are 4 properties when it comes to token bonding curves. But let's take a little look at understanding how token bonding curves work again. Okay, so if I want to buy 10, there are 30 tokens, and I want to buy 10 tokens. I can buy them anytime I want, because this function is governed by smart contract. I basically just send my collaterals to smart contract and tell them that I want to buy tokens. It's like, okay, what he does, he checks. So this is 30 tokens, initially $30, and then he checks, okay, you're gonna buy 10 tokens, $40, and you're gonna buy 10 tokens, which is 40 tokens now, and the token increase is 40. So how much is a quick test? How much do I have to pay in total? It's actually the area under the curve, because every token is a different price. So to get the different price, you basically integrate the function and area under the curve, just basically mathematics stuff. But you just need to remember, it's area under the curve is the price you have to pay. So this part, and that's it. It's a simple model. Where does the collateral go? I say that you give collateral to the smart contract. Smart contract defines this line, remember? And the collateral goes to this thing. We call it a pool balance or pool reserve. It's basically just a collateral that keeps everything. And this is what the thing that is supporting the curve. Okay, now I've got this, and because I pay this amount, I pay, and then it goes into collateral, and then it increases the triangle. Now I realize, okay, it's been fun, I like it. Now someone else wants to sell, and you can sell it anytime you want. So you sell it, the guy sells 10. So when I buy, 10 tokens it's being minted, and this guy wants to sell 10 as well. So 10 is going to be burnt, and by being burnt, it means that it's going to be invalid. The tokens can't be used anymore, and the prices also decrease. Now prices decrease, and the supply also decrease. Now the smart contract needs to know how much of the pool balance I need to give to this guy who burned the token. And it's basically the area under the graph too. And it reduces the pool balance and pool supply. So this is, in general, how it works when someone mints or burns token, or someone buys or sells tokens. So what are the 4 properties then? The first one is that it's always liquid and continuous. The smart contract is operating all the time, and it's always continuously operating. Prices are hard-coded, and prices in general increase when supply increases. The prices are hard-coded because it's governed by a mathematical formula that is going to be in the smart contract. Which brings to the third property, that smart contract governs the system. No one human can go in and alter it. The smart contract is governing the system by the mathematical formula. And something that's very, very important is that this system allows a user who owns the token to have a claim on future cash flow. So this is a very basic, simple model. I didn't go into very much details. But basically, this pool balance and pool reserve can continue to increase when the ecosystem itself generates revenue. So every time the ecosystem generates revenue, maybe 10% of the revenue goes into the curve. So the curve will continuously increase every time there's revenue coming in. So this is important because if we're going to have an ecosystem that it's just going to be based on people coming into the ecosystem and going out, it's called a Ponzi scheme. And we're not running a Ponzi scheme over here. We're running a very sustainable incentive mechanism that incentivizes people to join and they can get a claim on future cash flow. So as the system grows, because more people are coming in, and also because the ecosystem is earning money, they can get more money from there as well. Because the pool reserve increases, and when they sell, the area under the curve increases. Okay, so those are the different properties. Now, we do this basic steps again, the what, how, and why. So what is token bonding curve? It's an automatic market maker. It's a contract that creates its own market without relying on exchanges. Why? Because I said that it's always liquid and always continuous, right? That means that you can mint or burn tokens anytime. You can buy and sell tokens anytime. So it's an automatic market maker. You don't need to go to an exchange to do that. The system itself does that. It's governed by a mathematical formula and controlled by smart contracts. How? As I mentioned, a formula function is governed by a smart contract, and then it will just automatically mint and burn and distribute the native tokens. Why? There are three reasons people use token bonding curves. Okay, so far there are three use cases. The first one is continuous fundraising. The second is providing liquidity in the market. And third is another way of curating the market. So we're going to look at the different aspects based on these three use cases: fundraising, instant liquidity, and curation market. For live projects, we have One Hive that looks at, it's a project that looks at open source crowdfunding and open source governance. It just looks at crowdfunding. OS Coin is the one that looks at open source governance. Common Stacks looks at combines DAOs and project funding. Molecule is a way to fundraise drug research, and they actually tag non-fungible tokens to the research of the drugs. So that's quite interesting as well. For instant liquidity, right now we just have Bancor project where it provides liquidity between different cryptocurrencies without exchange. And the cryptocurrencies we're talking about are not, it can be the very heavily traded ones, but for those you can also go to an exchange because it's very easily traded. But Bancor project, basically you want to provide liquidity for projects that are not traded so much. We don't have so much demand on exchanges, and Bancor comes in to solve that using the liquidity. We're going to talk about that in the one of the sessions. And curation market, basically, what tokens are in this area in token bonding curve? It's a tokenized signal to say that this item is good or bad. And so we have stuff like projects like Relevant, decentralized news and content. We have Meme Factory, so they basically trade memes, and they support memes that will probably do very well. It's like a little game, and it's very funny. People are actually trading them. And you have Ocean Protocol, it's a bit more serious project. It's used to curate AI data and in the data exchange. So these are various live projects. The biggest one implemented right now is Bancor project, and I think the second biggest is Ocean Protocol. So there are four considerations when it comes to token bonding curves. We've got intrinsic value. How does it have any intrinsic value, and how is it being derived? What are the different risks and ways to mitigate the risks? The different curve functions, which is something that I want to spend a little bit more time talking about. It's very interesting. And what are the factors to consider? Okay, so let's get started. So when we talk about intrinsic value, we're going to look at the three functions again. The three use cases for fundraising, instant liquidity, and curation market. When we talk about fundraising, the intrinsic value comes from entitlement to future cash flow. You can change that. You can also basically, when people enter fundraising or they're raising funds, one of the reasons why they join or they're incentivized to join, it's because they are entitled to the future cash flow. They're entitled to the project earning money in the future or having increase in value, and they can cash out. So that's one of the ways to get valuation or to increase the value of token bonding curves when it comes to fundraising. So something that you can consider is you can factor in contributions. Maybe instead of when we talk about fundraising, and because it's a continuous curve as one of the first property, maybe instead of the mathematical formula, looking at entitlement to future cash flow based on the tokens that you buy, it's going to be the entitlement you get to the future cash flow is based on a proportion of the total supply in the market. Okay, it sounds very confusing. We'll talk about that later anyway. So it's basically ways to ensure your people who are the funders, that they can get future cash flow. That's the basic premise. And then you can play around with the math based on the different objectives that you want. The second one is instant liquidity. So the intrinsic value comes from ease of liquidity. It's almost instant. The availability of liquidity, which is it's also instant and constant, because it's always going to be available. And lastly, it's the network to other tokens. So when you can liquidate something on Bancor, you can take that and liquidate to and you can buy other kind of tokens that's available in the entire Bancor ecosystem, which is very interesting and adds a lot of value to joining the Bancor system. Otherwise, if you're just in the Bancor ecosystem and you can only liquidate one token, and you can't do anything else with that, it's a little bit pointless. And lastly, curation market. So it's also entitlement to future cash flow, because as you know, the memes that you bet on, or the kind of news that you curate, as more and more people agree and buy the tokens of that, the prices increase and it gets more popular, it gets more adopted, and you can cash out, which gives you entitlement to future cash flow. You can also, it's also a way to accurately signal the market sentiments. So if market really likes that, then it's being shown in the token prices and token supply. So these are the different values that comes from the three use cases. What about the risks and how to mitigate them? When fundraising, big problems, pyramid schemes, Ponzi scams, pump and dump. So these are common scams and common risks involved. And it's a lot more evident in fundraising. And also because, when we talk about the math, we talk about everything is just governed by math. You can hack it, and you can design the math in a way where it's a Ponzi scheme. So how do you do that? How do you mitigate that risk? You can have stuff like a time lock for selling tokens. So you're basically having a lockup period that you can't sell your tokens until the project reaches a specific maturity. Or you have a premium for selling tokens. So remember when we talk about the curve, we have the function that is governed by the smart contract. We have one function only, and that governs the buy function and the sell function. However, we can also make the line into two different lines, so that the buy curve and sell curve are two different lines. And then the selling price is going to be lower than the price you buy, and so that revenue difference, the spread, will always go back to the ecosystem. The other one, which is a lot more extreme, is that you don't have a sell function. The smart contract only handles buying of tokens, and if you want to sell it, you have to go to an exchange, you have to go to a secondary market to sell it. The next use case is liquidity. So one risk is that because prices increase as more supply increase, right? And if a big player comes in, if a person comes in to buy a lot of tokens, then this will massively affect the price. And if I know that, maybe my friend is going to buy 1 million tokens, I can cash in on that. What can I do? I can have my transaction validated first, and I pay a small amount of money. When his transaction is validated, prices go up so much, I can sell my token at a profit. And how can I do that? I can pay super high transaction fees so that my transaction goes first, and then the $1 million transaction goes later. That's how I can guarantee that I will have, I can buy tokens at a cheaper price before this big player comes in. So ways to mitigate that risk, very simple, to make sure that you have a maximum transaction fees on each transaction. And you can't inflate the transaction fee to be so high. So that it's fair for everyone. And next you have curation. Lastly, you have curation market. So curation market, one of the biggest problems is that you've got big players coming in to manipulate the data. You have like Sybil attacks where they keep voting, and the vote or the tokens available, it's not responsive, or it's not showing market demand, but actually showing manipulation of data. So what you can do, you can look at continuous staking and curation. So instead of one-time curation of the ecosystem, or the token bonding curve requires you to continuously keep staking, keep adding, and keep curating, and keep buying tokens to make sure that you really trust in this product you really trust in this specific token, prices going up. So these are just some examples of ways to mitigate risks. There are a lot more risk out there, and the risks are also very specific to your project and the objectives that you want to achieve. And when you can think of the different risks, you can start brainstorming and creative new ideas of how to resolve them and how to mitigate them. And next, so this is a very fun part. We look at curve functions. There are 6 curve functions that I want to talk about, and basically these are some mathematical formula that I have just played around with and trying to understand how it affects the ecosystem. And when we look at, we have 6 of them, and I'm going to go through 6 of them and understand what they mean. So the first one is the most basic. It's linear function. It's the function that I showed you just now. The formula is really simple. Y equals mx plus c. And you can change m, you can change c, and x is basically the supply of token, and y is the price. And it changes accordingly. You can also see how the graph changes, the gradient. You can define all of these. It's a very simple idea. It's linear, so prices increase and supply increase and prices increase at pretty much the same rate. The other one, the next function we're going to talk about is power function. Power function is y equals a to the power y equals x to the power of a, and a changes. So what a changes is how steep or how curvy the curve is, and in general, once again, it's as supply increases, demand increases. The difference is that if a is very, very small, then you can see that it's super, super steep. And if a is much bigger, it gets more and more flat. So it depends on the kind of it's a curve, and the curve can be super steep or super flat or just curvy. And the curve function is we call this a convex function. And basically, prices don't increase so much initially, and then as demand increases, prices soar up super high. And sometimes you might want this kind of function, sometimes you don't. When prices are soaring, you want prices to increase marginally at first, and then when prices increase super high and exponential, it can be quite risky. It can make the ecosystem quite volatile. Exponential function is basically the opposite. It's a to the power of x. It's another curvy function, but the curve is different. It's a different kind of curve. See, power function is basically the curves just goes very straight or very horizontal, and it curves this way. Exponential function is where the curve is it's a lot rounder, and the increase changes. The increase it's a lot more flexible. You can change a little bit more things. So this power function and exponential function have the same idea, is that initially the function doesn't increase so much, and then suddenly it increases by a lot at the end. So this can be both risky and good. We're going to talk about that later. I just want to introduce the curves to you first. The other curve is a logarithm function. It's basically y equals a log x plus b, and this is a concave function. Basically, you have exponential increase at first, so it increases very quickly, and then it kind of plateaus out. So it's if you think about it, it's like a steady state. It plateaus out, but initially the prices changes super quickly, so it can cause a lot of volatility. And a variation is where we have both an exponential function and a logarithm function, and plus some basic principles of linear functions into that. The variation is like a mix of everything. So it's the function that we have is m is 1 plus a, where a is zero. It's a number only from 0 to 1, which means decimals, and then you have log x plus b, and so it has a different type of function, and you can see that as the a changes, the shape of the curve changes. So the shape of the curve now kind of combines this exponential function plus logarithm function together into this curve. And basically, why I want to show you this variation curve is that there is no one function, there is no like linear function, power function, exponential function, or log function that's perfect for an ecosystem. It really depends on what's your objective, what you want to achieve, and how does these numbers, the M, the A, the B, how will they affect your ecosystem? You can engineer all of these parts and kind of create the right curve for your token ecosystem to achieve the objectives that you want. And this is where I talk about token engineering, because we're engineering the kind of features that the tokens have, the kind of curves that the token will be embedded with. And this is a lot more fun because, you know, with power, exponential, and log function, the curve is always the same. No matter how much you change, if it's concave, it's concave. If it's convex, it's convex. But with this variation, you can see that it goes from concave, it can change to convex, it can change based on how these values change. And we want to create a curve in your token bonding curve that is dynamic, that can have a lot of different shapes based on your different functions available. Why? Because maybe when your ecosystem grows initially, then we want it to look specific ways, and as the ecosystem grows to a different stage, we want it to look a different way. We want the curve to behave in a different way. And this can all be done with math. Like, math is one of the best things ever, and this can be done with proper engineering using math to design the kind of curves that you want. And the first 5 curves, I'm just generally talking about them because right now all the functions, all the token bonding curves are in 2D. You just have 2 axes, x-axis and y-axis. Another, if we start thinking a little bit more innovative, start thinking out of the box, we can start creating 3D curves. Instead of just token price and token supply, we can have a new dimension. It can be, a new dimension can be what's the price of something else, or what is a different factor and dimension that will affect the pricing of your entire ecosystem. So maybe it can be the number of active users in the ecosystem that could affect the pricing of your tokens, and you can plot a 3D curve. I was trying to plot them, and then I messed up real bad, and I didn't spend enough time to start brainstorming. But basically, you just have a new dimension that affects your prices in a very mathematical way, in a very systematic way, in a very logical way. So what I want to talk about in the end is that with curve functions, we can talk about the various objectives that we want, take them out, put them into mathematical logics, and then just plot them into graphs. From there, we can understand a little bit more about how we can engineer and design the tokens to achieve the objective that we want. So I want to look at these 3 curves and talk a little bit more about these 3 curves. We've got linear function, exponential function, and log function. When we talk about linear function, I said it's quite good, right? Because it's just a function that prices increase linearly. I mean, they are not supposed to keep turning up and down. Yeah, I just made a short video to show what happens when I change M and C, how the curve actually fluctuates. But basically the curve is a straight line. The curve doesn't move. What happens? Why is this good or not good? It's good when your ecosystem is very small. It's good if you have like about 10, 20 people in your ecosystem. It's a small niche community, and they will buy your tokens and they will trade your tokens. Then it's good. But as the system continues to grow, then you're going to look at crazy increase in prices in the end. Then the first few people will get very unfair good advantage as the system continues to grow, because it will grow, it grows linearly, and then people, it gives them very unfair advantage. So what we want to do is maybe we want to look at how can we incentivize curve going up at first, and then maybe towards the end when we're reaching mass adoption, or when we're reaching more people coming in and joining in, maybe we're going to look at a little bit of plateau, stopping a little bit and not increasing so much. But at the same time, when it's starting to increase at fast. We want it to increase a lot less because we want to incentivize people to hold the tokens a little bit longer, a little bit more. So how can we do the first part? How can we make the first part a little bit more, how do we make the curve a bit more upward sloping so that people will be incentivized to save? That's why we have introduced Mr. Exponential Function. You can see it's a curve like that. And once again, I'm changing A. I'm doing a short video to show you what happens when I change A. And the curve, basically the curviness changes. And if we just focus on one of the curves that's available, you can see that initially the curve is quite gentle, it's quite curvy, and at the end it's basically a very, very straight line. And it's good, initially it's good that it's very curvy, which is an improvement from the linear function that we have, remember? When it's very curvy, the price increase is much slower compared to the linear function. So the price increase is much slower, so it disincentivizes pump and dump. It says that, okay, I don't want you to pump it. The prices increase so slow, I want to save my tokens a little bit longer so that if I save my tokens a bit longer and then when it reaches maturity, when prices go up quickly, then I can sell. So that's what I want. So then I achieve my objective of asking people to hold your tokens a bit longer. But now if you think about it, okay, so that's good. I got my objective. It's an improvement from linear. And now the prices here increase so fast. Can you see? Like super crazy fast. And is that good or bad? Then we have the same problem as the linear function, where at the end, prices increase, basically almost a straight line, increase so fast. Then it increases a lot of volatility, increases a lot of speculation, because prices changes so quickly, people will be trading it all the time. There's a lot of speculation, there's a lot of volatility. And that's not exactly what we want. So now we want to look at, okay, I want to improve my model, and I want the end to be flatter a bit, because as my ecosystem continues to, at the end, more people, more supply in the ecosystem means more people coming in. And I want it to be a bit flatter, a bit more plateau, because that's a better model to incentivize people to stay and incentivize people to continue, just to be in the ecosystem. So what can I do? Then I look at the log function. A log function is where you can see that the line here, towards the end, it just kind of plateaus out, it's good, right? It's exactly what we want. But if you look at the beginning, it's a strange way. It increases so fast. It's exponential. Now, towards the end, we achieve the objectives that we want. But in the beginning, we don't exactly achieve the objectives that we want because prices changes so quickly initially. And early investors will probably not hold. Early investors will look at this as opportunities and try to sell the tokens. Then we had serious pump and dump in this situation here. Because it's not so attractive for investors to hold so long, prices don't increase so much. So they want to sell all their tokens in early stage. So this doesn't work as well. But in general, we want something very gentle increase at the start and gentle increase at the end. And this could be one. It really depends on the kind of objectives that your ecosystem wants to achieve, because depending on that, the kind of curve functions can be very varied. So that's why this variation includes both log and exponential function into the mix for you to go and explore how it can affect your ecosystem. So it's curve functions. I think it's super interesting, it's super fun. These are the other factors in general that you want to think about before you start thinking about how do you put them into a math formula, into a curve function. The first one is, do you want to incentivize early adopters? And how do you want to do that? Do you want price stability at the end? So incentivizing early adopters is where, our slope is this part, the exponential curve, the slope is much gentle so that it incentivizes people to hold your tokens longer. And there's price stability at the end, where it's a bit flatter so that prices are a bit more stable. So price stability at the end. Then you can look at do we want the cost to appreciate or the price to appreciate on the factor of supply increasing, or maybe the productivity of platform or token. So this, we can also have all three together. So the price, the supply, and the productivity of platform all together, and we can use our 3D graphs and 3D curves, and kind of interlink all of these factors together. How can we prevent abuse or arbitrage? We want to make sure that the curve you design doesn't allow for arbitrage and doesn't allow for abuse. How do we grow the growth of underlying product? So, for example, the productivity of platform or the ecosystem, we can factor in the S curve of technology, innovation, and new ideas, and put it use that in the Z-axis for the 3D curve, maybe. And then something you also want to think about is, do you want your returns? How do you want to make sure that your returns are appropriately attractive across all range? So the returns here are basically, the same throughout all range. The returns here, it's very little at first and then very much at the top. And here it's very little at first and a lot at first and very little at the end. So you want to, based on the objectives that you have here, you look at what is appropriate for your ecosystem and what's the kind of, do you want them to be, do you want the returns to be equal throughout all of the ecosystem? So those are the factors to consider. And now just 3 basic questions for you to get started and for you to start thinking about how to implement and if you should implement token bonding curves. The first one is, how many users can your project sustain and attract, both at introduction stage and at steady stage? So introduction is where, the slow curve going up. Steady state is where you kind of want it to plateau, where we reach mass adoption. Are both early adopters and late adopters equally incentivized to participate? And do you want them to be equally incentivized? Do you want to incentivize early adopters more to reward them for joining? Or do you want to, incentivize them equally because they are all equal? And can you attract the amount of capital needed to take the project to an adequate level of adoption? So maybe can you do that? Or maybe you have to look at lock-in of tokens so that you have an amount of capital needed to run your project and start earning money and start growing the token bonding curve. So these are some questions to get started. And so you can start thinking if token bonding curve is the right curve for you. And now we talk about the variation. So there are 3 variations now in the, just kind of like edits, because those previously is just the general token bonding curve. Now we look at the different edits, the different variations. The first one is augmented bonding curve. So few things is that the tokens are, some part of tokens are being minted in phase 1 and locked up for a period of time. The objective is to incentivize early adopters and to govern, and for it to be governed in a continuous organization. So the concepts being taken in place is a typical bonding curve. You've got funding pool, lockup mechanism, and inter-system feedback loops. It comes from the first principles in physics using energy conservation equation. And basically what it does is that you have 2 pools. You have the reserve pool, which is the collaterals, and then you have the funding pool, which is supported by the foundation. Every time a token is being burnt, there's a exit fee, or there's like a interest rate or transaction fee that's being generated where you have to pay. So that when you burn your tokens, you get slightly less back, and then that money goes to the funding pool. And also tokens are being minted and locked up in phase 1. As you reach mass adoption, then there'll be tokens being minted in phase 2 that can be just used. All of these are tied into governance in a continuous organization. So people with tokens being minted and locked up, to unlock it, they have to be voting and they have to be active in the governance mechanism or governance protocols to be unlocking their tokens. So it's taking a lot of different aspects coming in together and taking token bonding curves to design this new incentive mechanism. Like I said, there is no such thing as like a perfect curve, perfect mechanism available. It's just depending on your objective that you want to achieve, and you want the ecosystem to work towards, and then you design that accordingly. So the purpose of this was to look at charity giving and look at funding different kind of charity projects. So this is the mechanism they use. The other one is dynamic bonding curve. So this is something I was talking about initially, where rewards are a proportion of the total supply. That means as the supply grows, if your reward is if your tokens that you own is a constant amount and supply grows, the proportion drops, and rewards will be based on this ratio. So what we want to do, the objective is to encourage constant participation. We want people to always participate. Maybe this could be a community-led project, and as more people participate, every time they participate, they are rewarded with tokens, and so their rewards will increase proportionally with the total supply, and so the tokens they own will be increasing proportionally to the token supply. And when they burn the tokens and get the collaterals out, the rewards actually increases. So we want to reward constant participation. And lastly, it's pure liquidity bonding curve. This is a very specific example where no revenue is being incurred, because now we want to provide liquidity, we want to provide trade, we want to be an exchange without margins. That means the smart contract doesn't earn money. All the money is being given back to the people or to whoever that trades. So there is no revenue incurred. It's just a medium to exchange low volatility tokens. So this is another variation as well. So your token bonding curve, it's not for you. It's not for people to join and then wait for the system to grow and then you pay or you earn money from there. It's basically a way to liquidate tokens based on the kind of demand out there, and everything is done in the mathematical formula. So this is something we will talk about in lesson 10. We have a specific example, and then we're going to look deeper at the math. So that's token bonding curve.